this video we are going to learn the remaining addressing modes, starting with relative addressing mode. So we have learned about what is relative addressing mode, and we have seen that this relative addressing mode makes use of PC in place of the registers, and effective address will be calculated as EA is equal to PC plus content of PC plus X, where X is a signed number, and this can be used in the branching conditions. Okay, main purpose is like for PC will be used to fetch the next instruction that need to be executed. So if it is in the case of branching statements, means in such a case PC need to be updated with some other address value that is not in a sequence. So branch target location also can be set with using this PC relative addressing mode. So a branching condition statement will be like this: branch greater than 0 loop will be the label to which this next statement need to be executed. So branch target location, that is loop, will be computed by specifying it as an offset from the current value of PC. So how to jump to this location? It can be set by making use of this X of PC, this instruction. Okay, that we can see with an example also. Branch target may be either before or after the branch instruction. The offset will always be given in the form of a signed number. Okay, signed number. So signed number. So we can see this with an example. So here the example is given like move 100 of PC comma R1. So as we have seen, 100 will be a new constant value. PC is the program counter where the current address will be stored. So in this example, PC is loaded with 2, and next instruction that or next value that need to be fetched will be like obtained as PC value plus the relative address, which means this 100 plus PC. So this 100 value, it will be there in the X register. So 100 plus PC, you will be getting the value as 102, and data that is stored in 102 location, that is 110A, will be taken and will be stored in the register R1. So in using this instruction, some data it is being stored in the register R1. Okay, so this is a case with the relative addressing, or another name is PC relative addressing mode. Next is the auto increment and auto decrement mode, in which auto increment, the effective address of the operand is the content of the register that is specified in the instruction. After accessing the operand, the content of the register are automatically incremented, or it can be decremented. So in case of auto increment mode, the content of the register will be automatically incremented so that it points to the next item in the list. So how it can be represented inside the instruction? Making use of this in the operand field. So RI within bracket followed with a plus need to be given. So how the effective address will be found? Effective address will be equal to RI. Okay, so if an instruction is having this operand, then operation will be performed like first an effective address will be calculated, that is the content of register given in the instruction, and after that the address will be incremented. Okay, so increment is 1 in case of byte size operands, and 2 in case of 16-bit operands, 4 will be in case of 32-bit operands. So this, if we are increment, means incremented by some value. That value will be based on the size of the operands, whether it is 32-bit, 16-bit, or 1 byte. Based on the bytes, the increment will be done. This is a case with auto increment mode, where the effective address will be taken first and then the increment will be done. So here consider the example R1, add R1 plus comma 3. So what is the effective address here? R1 will be the effective address. So from R1 you will be getting one address. That value will be added with the 3, and then this R1 will be incremented by 1. That is shown in this register transfer notation also. So here R1 plus 3. So that is the first task performed. Then R1 will be incremented by 1. Okay. Then auto decrement mode. It contains the the instruction will be having the operand in this format, that is minus Ri. So in the previous auto increment mode you will be having Ri plus, in this minus Ri. What does that does? It decrements the Ri first and then the effective address will be computed. Okay. In the previous auto increment mode, first the effective address is taken from the content of the register R and then increment operation is performed. Here first decrement operation performs and then it computes the effective address based on the result obtained. So content of register specified in the instruction, it will be automatically decremented and is used as the effective address of the operand. Okay. So here move D0 comma minus A7. Okay. So first it will be pointing to some location, then decrement it. So after performing this instruction, what it does, A7 will be decrementing, pointing to this location, and then to that location D0 value will be stored. Then similar is the case with the next instruction. A7 again it gets decremented, pointing to the next memory location. D1 value will be stored. Again it decrements, D2 value will be stored. Then next see it in these three instructions auto decrement mode is being used, and in case of this last instruction A7 plus, in such case what you need to do, first the content of A7 will be copied to D2 and then only the increment operation will be done. So, this value will be popped and then only means if you are making use of stack means like that, else if it is in memory, just we are copying the element from the location A7 to some D2 and then increment the value pointing to this location where D1 is stored. So this is the operation performed making use of the addressing modes. So combining together we are having this much addressing modes. Immediate addressing mode means the syntax that is being used is hash value, and in such a case you will be getting operand directly from, that is the value will be obtained in the operand field itself. So operand is equal to value. Effective address is not being computed in that case. Then next is in case of register means the instruction will be having registers alone. Both the operands will be having the registers and effective address will be like the register value that is represented the registers. EA is equal to RI. Then absolute or direct means a memory location will be specified in the instruction. So effective address will be equal to that memory location itself. Okay. And then indirect addressing mode means you will be specifying either the register or the memory location variable, but in that not the actual value will be stored. It will be having another one address where the actual value will be stored. So effective address will be like it should be enclosed within the square bracket to get the actual value. So RI and LOC, here it represents some here represents some memory location where the address value is being stored, and that address will be having the actual value. Then next is indexed addressing mode, in which notation is x of ri. Effective address computed is e is equal to ri plus x. Then base with index means we will be having two registers including the base register, and effective address computed is ri plus rj. Base with index and offset, in that case you will be having base register plus the offset value also will be taken. So effective address will be taken as ri plus rj plus x. Then relative addressing mode, it makes use of PC instead of the register value. So the notation is given like this, x of PC, where effective address is equal to PC plus x. Then lastly it comes auto increment and auto decrement addressing mode, where the notation is in case of auto increment the notation is given as ri plus. So in this case effective address will be the content of ri, and the operation performed is like first effective address will be taken and then increment the address with its byte that is used to represent the word. Similar is the case with auto decrement, but in that case effective address is taken after decrementing the value in ri. Okay, so this is these are the different addressing modes in order to represent the location of the operand that is given in the instruction.